Okay, I'm just starting on a lesson where we're actually going to talk about the surface area of a prism. We've done the volume, but now we need to know, if I wanted to cover this up, how much paper would it take to cover each side just? So we need to know the area of each face of any prism. So I would start off with a cuboid. Then I said we're going on to right-angled triangular prisms. Well, it's important that we talk about right-angled ones at the moment, because often you only get told some of the numbers needed with them. The end of next week you should also be able to do isosceles based triangle prisms as well. And finally we'll wrap up with what bits do you need to be able to do a cylinder. Okay, so we're going to go through these three. Each time I'm just going to do a little quick reminder, how can we calculate the volume? So remember, the volume for a prism is the base times the length, and I suppose I better put the numbers in. So this one is 3 centimetres deep, 4 centimetres wide and 7 centimetres tall. So the volume for this, we would multiply the base. It doesn't actually matter with a cuboid which one you call the base. But if I took the base and I multiply the base, 3 times 4, that's the area of the cross section, and then multiply that by the length or the height of it in this case. That will give me the volume of that cuboid. So that's 12 times 7 is 84 centimetres cubed. Now surface area, in previous years when you've done just single ones, you probably did them in pairs, bottom and top, front and back, left and right. What we're going to do with this to help with the other ones is, what we're going to do is we're going to talk about the ends. Now the ends on any prism should be the same, so there's always 2 lots of that. Sorry for the hesitation, one of my chat boxes just popped open. So we're going to talk about the 2 ends and calculate the area of those 2 ends. These will always be in pairs. The 2 ends will always be 2 shapes. So the top and bottom, I can do those as 3 times 4, which is 12 centimetres squared. Then what I'm going to do as I go around this is I'm actually going to label the sides, and I'm going to label them A, B, C, D. So I'll start with A at the front. Actually I'll call it A, B, C, D. So we're talking about these rectangles on the sides, and for all prisms it will be the rectangles. So we've got the ends, and then we've got the rectangle and what I call the tube. And on the end side we need 2 of them. Okay. So the rectangular tube is made up of 4 pieces. Yes, they come in pairs, A and C, B and D. So the rectangular tube, we'll do A first, which is 4 wide, 7 tall. I'm going to keep these in the same colour, so let's go blue, B, which is 3 deep, 7 tall. Going on the back, C, the dotted rectangle at the back, and that is 4 by 7, and 4 by 7 is 28 again. Notice we're getting our pairs that we're used to. And D on the left, it's 3 times 7, which is 21 centimetres squared. If I add all of those up, the total surface area, and we use S normally for surface area, and I believe it comes from translation from Russian, where we talk about section. So we're saying the surface area which you would call section in Russian is S. And that is just the sum of all of these. So 12 plus 12 is 24, 52. Let's just grab a calculator and make sure It should be 42 and 56 and 24. Let's go 12 plus 12 plus 28 plus 21 plus 28 plus 21. And that's 122 centimetres squared. Now, sorts of things that can happen with this is someone might ask you, how much paper do you need? You need 122 centimetres squared if you can cut it precisely. Questions sometimes talk about paint, and they might say 1 litre of paint will cover maybe 250 centimetres squared. How much paint would you need? Which would be just less than half a litre in this case. They're the sorts of things that this allows us to work out. So let's move on to the next one and look at the triangular, right-angular triangle. I do keep saying this is right angle, and it is. It's a right angle in the base there. And this one is 2 centimetres deep, 3 centimetres wide, and I think I made that 5 centimetres tall. So just as a little recap, let's do a quick volume. The volume is the area of the triangle multiplied by the length going backwards. So that's a half times the base, which is 2, times 3, and then multiply that by 5. And that gives me a volume of 15 centimetres cubed. Or we could have done the cuboid. 2 by 3, 6, times 5 is 30, and half it because we've cut it in half. That cutting in half trick doesn't work for what we're doing now. And I've just realised I've got to calculate something else first. I need to give you an extra bit of information, which at the end of next week you'll be able to calculate. And what I haven't told you is the length along the back there is 3.6 centimetres. How I did that you'll be doing next week. Okay, it's to do with Pythagoras Theorem. So let's do the surface area of this shape. First of all, think about the ends. Well, the ends are these 2 right-angled triangles. How do I calculate the area of the triangle? Well, we ignore that 3.6 because we want the base times the length at right angles. So the area of the triangles is 1/2 times the 3 times the 2, which gives me 3 centimetres squared on the bottom, and we've got a repeated one for the top. So that was the top, and the bottom is the same. Then the same thing as I said last time, we're going to look at the rectangles. They are always rectangles, and I've got a rectangle with the 2, a rectangle with the 3.6, and I've got a rectangle with the side 3. So we're going to calculate those separately. So that should be bottom and top. So we've got 3 sides to do, A, B and C, and they are all rectangles, so I'm going to label them as rectangles. Rectangle A is 2 by 5, which is 10 centimetres squared. Triangle B is the 3.6 times 5, and I'll grab the calculator for that. 3.6 times 5, which is 18. And side C, which is 3 times 5, 15 centimetres squared. So the total surface area, the sectional area, is the sum of all of those. 3 plus 3 plus 10 plus 18 plus 15. Do it on the calculator again. So I've got my 3 plus 3 plus 10 plus 18 plus 15, and that is an area of 49 centimetres squared. And again, the sorts of questions you'll get asked are things like how much wrapping paper is needed to cover that shape, or how much paint is needed to go on it, or how much material if this was to be a tent, things like that. Let's go on to the cylinder, and I've just thought of one more I might want to do in a minute, or at least remind you of how you can calculate it if you've been given enough information. I'm going to give you this one, and I'm going to tell you the diameter at the bottom is, I'm going to say 7 centimetres, and the height of it is 5 centimetres. These could be units in of everything to do with meters, or they could be in kilometres. In fact, on the worksheet, for some reason they do surface area of things in kilometres, which is not really something feasible. You might get something kilometres long, but you don't often get them kilometres wide and tall as well at the same time. If you're talking in those terms, you're talking about covering something like the Mount Everest. So, first of all, let's just do a quick recap on volume. So the volume for this is the area on the end. Notice the area on the end is knots by 7. Area, pi r squared, sounds like the area to me. So it's pi. The radius is 3.5. That's my area of a circle. And I multiply it by the length, 5. So I'm going to take my calculator. Pi times 3.5 squared multiplied by 5. And that gives me 192.4 centimetres cubed. Sometimes called cc's. And they are actually the same as millilitres. 1 centimetre cubed is 1 millilitre. All three of those are the same. Right, the ends is easy. Ends, we've got a top and a bottom. They are both based upon this diameter. So the area on the end, top, is going to be pi times my radius squared, radius 3.5, remember to half it if you've been given a diameter. And that gives me the same length I had a few moments ago. Let's put it back into the calculator again. Let's go and edit and remove that volume part off. 5 squared. So pi times 3.5 squared. Press equals, and I get 38.5 to 1 decimal place. Bottom is the same, but I'm going to do something a bit weird. I'm going to store this number in a memory on the calculator. And the reason I'm going to store the value here is there's a lot more decimal places here, and depending on what I need to do in later parts of the question, I might want to use this more accurate value than the rounded one. So to store on a calculator, I'm going to use the store function. I do shift, store, and you say which memory do you want to put it in. Well, this is a circle, so I'm going to put it into C. Press enter. So that's now been stored in my value C. If I cancel it and do alpha C, I get my 38.48 again. Just to help me, I'm going to put that as a little note. I've stored it in memory C. So as I work through on my calculator, I know which memory has this value in accurately. Now here comes the hard part. There's not lots of rectangles for this one. There is a single rectangle, and what we have to do is we have to unpeel the rectangle just like a piece of paper from the end, and I'll just show you on some paper. There we go. So I haven't seen you for a little while and you haven't seen me, but yes, I'm still here and I managed to get my hair tidied. So I'm going to just quickly make a cylinder from a piece of paper, just by folding it into a tube. So there you are. And all we're looking at is the side piece, the piece that comes along. So what we're going to get is when I fold it out, I'm going to get a flat rectangle. Okay. So where did the lengths come? Well, this long side is the height of my cylinder, and the curved part, the circumference at the top of the circle, is what gives me the rectangle long edge. It's very much like when we cut up the sectors earlier last week doing the area of a circle. So we'll go back to the notes. I can disappear from here now. So I'm going to go back to the rectangle along the side. So the tube is made from just one rectangle. Tube. It's made from one rectangle. And that rectangle has the same length as the height of the cylinder. Is 5. Height is 5, or length is 5 from these formulae. And the distance around here is the distance all the way around the rim at the top. Now that's pi times diameter. That's the circumference, or pi times the diameter, or 2 pi r. So to get the area of that rectangle, we need to do pi d, because I was given d, pi multiplied by 7, then multiplied by the height of the tube, which is 5. So that's the circumference at the top multiplied by the length, and it gives you the curved area. This is actually a curved surface around the tube. Put that into my calculator as well. Just try not to show you all the other programs I've got running. Wrong one. Let's just check that's the one with C in it. Yeah, so I can get that one out of the way. I've got a quick key, and sometimes when I press the quick key to bring up the calculator, I bring it up more than once. So this curved surface area, I have pi times 7 times 35. So yeah, show that calculation. Times 5. I think I said 135 there. And that is 109 point. It's 95. Got lots of extra digits. So we can do some practice with our rounding here. I want to know one decimal place. The 5 says round it up. That rounds the 9 to a 10, which carries a 1 into here. That rounds this up to a 10, which carries a 1 into here. So my actual number to one decimal place is 110.0. To get my total surface area, it is the top and the bottom plus that 110. So I'm going to use my previous answer and add to it the plus the C, the circle at the top, plus the circle at the bottom, and this gives me a total surface area of 186.9. centimetres squared. If you had done it with these rougher numbers, you probably would have got 187. Most of the time that would be acceptable, but notice 187 is a rounded answer based upon these ones. This next decimal place you can't be too sure of. You can't guarantee that that's the right number. So We gave answers to 1 decimal place, but I've kept working with more accurate numbers by using the memory in my calculator. Okay, so I use the memory in the calculator. There's one other thing that I know is in the diagrams that are in the exercises. I'm not going to spend long on it, I'm just going to remind you. If you've got a trapezium on the end of your prism, you've got a length here which might be 7 centimetres, might be 3 centimetres at the back, 4 centimetres along the top there, and I doubt that would be 3 centimetres might work on this side. When you come to do the top and the bottom, the ends, you need to use the area of the cross section is 1/2 of the parallel sides added together. What they say is A plus B, multiplied by the perpendicular height. You have to know this height here as well. Now, off the top of my head, I can't calculate what that is, but that's the other number. The 3's don't come into that part. You've got 2 of those, and then you've got the rectangles. The tube has a rectangle, which is 7 times, if this is 9 centimetres tall, you've got A, which is 7 times 9. B, side A, side B, side C, and side D. So side B is 3 times 9. Side C is 4 times 9. And side D is 3 times 9. So remember, you've got to look at this, and this is the perpendicular height of that triangle. Okay, so off you go. There's a whole worksheet put together for this.